Well, hello everyone, and welcome to this special SSPI Canada webinar, the second in our series. I'm Lou Zaccarella, the Director of Innovation for SSPI Global, and we welcome you to this episode, which is called the New Space and Satellite Ecosystem. This webinar is brought to you by SSPI and the SSPI Canada chapter. The mission of the SSPI Canada chapter is to stimulate the growth of the satellite industry in Canada, expand the research, innovation, and development of the industry by attracting world-class talent and promoting the development of satellite professionals. To fulfill its mission, the SSPI Canada chapter is linked with its members in various industry bodies, education, and government organizations. For more information on SSPI Canada and to learn how you can join, visit sspi.org. A special thanks today to the corporate partners of SSPI, EchoStar Hughes, Access Intelligence, and the law firm of K&L Gates for their ongoing support of the programs of SSPI. Well, our industry has certainly changed. Before we went on this morning, we were talking about the Mercury astronaut program and some of the things that took place when nobody really knew the capabilities of satellite fully to do the kinds of things that are indispensable in the world. But we've come such a long way that we are now part of the ecosystem that is driving significant chunks of the global economy. Places that were never spacefaring nations or regions, like Estonia, which announced yesterday that it was going to continue to develop startups for the space industry in its science park. The nation of Nepal now has a space agency. And so we're becoming a more mainstream agency in creating all kinds of ecosystems, programs, and economic activity based on the technology that we think has transformed the world and continues to do that. The new space and satellite ecosystem can mean a lot of things. But it certainly means that the flows of data from satellites and across networks is profoundly changed. It means that new businesses and business models are emerging just about every day. And it's really hard to keep up with the flow of new businesses that are being created, but it's great to see. For our discussion today, what we thought we would do is look at a very important and exciting trend, which is how AI, artificial intelligence, is meeting this, and how it is working with connectivity infrastructure and technology providers and classic, if you will, satellite industry companies and space companies that are transforming governments, businesses, and touching nearly every segment of our society. So with that as our general pretext, let's get at it. Daniel Shapiro is with us today. Daniel is the CTO of Lemay.ai. For those of you who don't know Lemay.ai, it's a specialized consultancy that provides artificial intelligence, machine learning, and deep learning solutions to companies. The corporation was founded by Mr. Shapiro and Mr. Matthew Lemay in 2016. Over the course of the last 2 years, they have refined their AI consulting framework, which now allows them to successfully deploy on multiple projects. Their website is Lemay.ai. Welcome, Daniel.
Hi, thank you.
Joining Daniel is Christy Damian. He's the Vice President and Business Development for Advantech. Advantech Wireless is a leading wireless broadband communications solution provider for the industry. Advantech is known for a lot of things, and especially for giving clients the freedom to achieve reliable connectivity anywhere in the world and accomplish critical missions of global significance. You can check them out at advantechwireless.com. And I really want to welcome Christy here because he has been so instrumental in putting SSPI Canada on the map. So good morning, Christy.
Good morning, Lou. Thank you for giving us the opportunity to be on this panel. It is a pleasure, in particular, to join the discussion with Daniel. We are very happy to have such a bright artificial intelligence company on the SSPI Canada panel today.
Yeah, we're really looking forward to this conversation. Just for the sake of getting our viewers centered on our geography, where are you both located today? Daniel, where are you?
We're in Ottawa, Canada's capital.
Canada's capital. And Christy, where are you today?
I am in Montreal, Quebec, Canada.
Okay, so we have Quebec and Ontario provinces represented here. And I'm going to represent the state of New York. I'm in Long Island today, coming to you. Christy, I'm going to start with you. This is really a big topic to sort of bite into and chew. But when we talk about the new space ecosystem, people do have various definitions based on their own business model, the markets that they're serving, and of course, the country or even the province where they do business. How, in your view, is the new ecosystem being defined where you are in Canada and also by your company, Advantech Wireless?
Well, Advantech started in 1987 as a pure RF company, focusing on design and development of solid-state technology for power amplification, for satellite communication. So we started developing and deploying, little, step-by-step, a 10-watt amplifier, a 50-watt, and a 100-watt, and so on. Here we are today in 2021, and we are developing 20 kilowatt of power and something like that, all solid state, all digital. So from our point of view, in the entire satellite ecosystem, it was always about power. And I will explain why. For example, a traditional VSAT system is run very efficiently in a TDMA mode, time division multiple access. We can share the bandwidth between multiple users with different modulation and error correcting codes, right? So if a user is in a remote location, he can receive his signal with, let's say, low modulation, 8 PSK, QPSK, he's fine. Somebody else might have a bigger antenna, needs higher data rate, maybe he will get 32 APSK. All of them on the same carrier. What's happening is DVB-S2 comes with this very interesting and very good algorithm, which is called adaptive coding and modulation, which if something happens in one site, we do not need to change all the sites, but we can address a specific site. So let's say it's raining at the site with 32 APSK. You don't want to give more power because it defeats the whole purpose. You will lower the modulation error. So that site, only that site will go 16 APSK or 8 PSK and so on. So there is a bandwidth and efficiency degradation there. If it rains at the hub, we have the same situation. Now the whole hub is affected. Immediately, most of the time, the uplink power control system will kick in, asking for more power. But the problem is if you have a multiplex of carriers, some of them are high mod codes, 64 APSK, 32 APSK, and some of them are BPSK, APSK. The low power ones might still be working, but the ones which are in high mod codes cannot transmit at higher power. They will generate errors because the amplifier needs back off. So again, we cannot transmit more power. We have to reduce the modulation. So that means decreasing the data rate and the bandwidth. So it's always about not having enough power. If we would have that enough power, then we would push all these high mod codes and maintain the efficiency. Now, we are now able to do that because we have building since 2015 unmanned teleports completely running and illuminating an entire satellite with a single antenna. We're putting there 3 kilowatt systems on a 13-meter antenna, and we can address every single transponder of that satellite. What is really needed and what is coming right now is the artificial intelligence part, which will bring to the table the RF orchestrator, because what's the best route to move the traffic? Machine learning algorithms will need to learn that path and to use it when needed. And could be a network of distributed teleports, which some of them, they don't even need to know how bandwidth is allocated.
Right.
And then going further into the design of the amplifier itself, we will be looking at digital auto tuning, phase combining, because different from a traveling wave tube, digital amplifiers are built phase combining multiple transistors. And there are phase differences between them. There are biasing differences between them. If we can have a machine learning algorithm that based on each modulation, each error correcting codes, each kind of data rate required and tolerance to errors can automatically learn and adjust the amplifier at the optimum, then you really have an intelligent power amplifier.
Yeah. Well, thank you, Christy. I mean, you really set up what we wanted to talk about, which was, how the current technology and the demands on it, as you say, can be orchestrated and enhanced by, I think you said RF orchestration. So AI becomes that entity that does that for us. So Daniel, your friend Christy really teed it up for you. You're the conductor of the orchestra now. You're the RF orchestra conductor. But what I want to do is understand Lemay.ai's view of the transformations taking place in the space and satellite industry to the extent that you guys decided to serve it. Tell us where you guys have arrived as you continue to scale, and then pick up on where Christy was going with regard to the importance now of the AI to do the kinds of things that are necessary with regard to the virtual teleport and the data transmission.
Awesome. So this is actually a really interesting industry. What's going on is something that investors will call deep tech, where you have two complicated technologies that plug into each other to make something even more complicated. As you just heard, the satellite industry is advanced. It's not a thing that was like born yesterday. It's at multi-generation scale. You have heterogeneous infrastructure. Some is old, some is new, both on the ground and in the sky. And so you also have different competing constellations that don't talk to each other, and you have deconfliction. So the bottom line is you're taking this growing, interesting thing called AI, combining it with this growing, interesting SATCOM industry that's growing in capacity tremendously. And many customers don't know their data is being shipped via satellite. It's like a channel people don't think about, but they also don't think about, like, is it raining? It's not a thing that people consider when they're like, I have to get my data from point A to point B. The real customer who's paying for the bandwidth, they don't actually realize if it's raining or not. They don't have to think about it. They just go like, send data. When you use the regular internet, you don't think about like, is there congestion over fiber lines? You don't think about it at all. You're just like, it'll work out. But it's someone's problem. And so the type of project that we actually have to do is go to real customers and apply machine learning to their data sets. So our operating model, to answer your question from before of like, where do we fit in rather than just like, where does AI fit in? We go to customers and train machine learning models on their data sets to help them solve problems, whether that's predictive maintenance to figure out when should assets be replaced, kind of figuring out residual useful life and avoiding overstressing the equipment. Sometimes you give the equipment a break. If, like we were just talking about earlier, if adding power doesn't make sense, don't just press on the gas and add power. Where it does make sense, go for it. And so you can do things like traffic forecasting, like automated ticket routing. It's also a little bit surprising for people to learn that like these networks are operated by people, just like every other network. So your fiber internet, never mind space, is operated by humans that like, there's not physical levers, but they manage the flow of information through these networks. They're not watching if like one person is watching Netflix. They're looking at like very high level flows of information and figuring out when should I shift bandwidth. It's not all automated. People think because of TCP/IP that like the internet is automated. The satellite system works the same way. It's operated by people. And so we help to build automation tools using the data set of the customer. And the example that I can give is ticket routing. So we work with network operation centers to look at their ticket management system. And when a ticket comes in, like a link down, great example, Christy was just mentioning, like a link goes down for whatever reason. It could be weather, it could be like something else, whatever.
Happens
But the idea,
Yep.
yeah, the idea is that those link down messages are handled by people. If you can route them to the right person, assign them to the right team who's going to mitigate the issue, or even in the best case scenario, if the machine learning can actually assess the link down and fix the problem, not just assign a human to fix the problem, those are all accelerations that make the capacity of the network and the resilience of the network better. So that's where machine learning fits in. to just make the current system of how the world works more efficient.
Right, right. I think that's very well said. Question now, and I don't mean to minimize what you guys have done in machine learning with regard to automated ticket routing for downlinks, because you also mentioned the repair component. But I know that you're probably like always looking to the next thing, right? Next problem to solve for a client for an industry like ours, which you say can be a very complex one. Is machine learning for something like automated ticket routing kind of the low-hanging fruit? And as you look down the road to this ecosystem the next 5 years, do you see other applications coming on that should really excite us in the industry and the customers we serve?
I'll give you a bit of a boring answer. I'm a super practical engineer, and so I'm like, what is the customer going to pay for? If it comes out of like the OpEx budget and not the capital expense budget, then it's easier to get done because they're like, we already have the money for it. Let's just do it. And so the operating expenses for like the network operations center is a place where you can find money. When you have to find new money for a capital expense, it's really slow. And you know, from the satellite business, everything is slow. Like, but money doesn't just like show up because of a cool idea. And so there is a lot of things like this where you go like, here's a cool idea. And there are cool ideas when it comes to, for example, maintaining assets. If you can save money by both on the ground and in the sky, spending less money, then that's a thing that the customer will pay for. But my more general answer to your question is, no matter how cool the idea is, first you have to convince someone to pay for it. Yeah. Then you have to experiment to see if it works, because unfortunately we're in the science business, not in the engineering business. I'm an engineer, but machine learning is about like fitting a model to the data and then checking if it works, but you don't actually know in advance if it's going to work. And the null hypothesis is very strong. So yeah, there is, because of that unknown factor, some even extra resistance to, for example, the science of the hardware side as well. It's not just about the software. It's about anything new has to be like proof of concept and then validated and like incrementally deployed.
Right. Yeah, no, I think that's a very, very good answer. And you know, that's how an entrepreneur and the head of a company would definitely answer it. So you get an A for that one. Christy, just to sort of bring it back to the RF side, I want to talk about how AI is impacting RF. I mean, obviously, Advantech Wireless has deep experience in RF. What would you say the major impacts are right now by AI?
Well, I would say that, first of all, Daniel is absolutely right. OpEx, if you can get money from OpEx, that's the way to go. So we had customers, for example, who purchased an entire satellite bandwidth, and we designed a teleport for them. And the technology was initially rejected by pretty much everybody in engineering, including the satellite operator, who said it's never going to work. And then the person who actually approved the program was the CFO. So when you show the money and the benefits, then people start to change their mind. So here you have a company who's buying an entire satellite, all transponders, and then we illuminate it and we saturate it. And because we have this excessive power available, we can run much more efficient modulation and error correcting codes. And they are left with few transponders not required. So suddenly you have millions of dollars of additional revenue, which you didn't plan, on which you can put other customers. So the initial expense in CapEx is covered in about a year and a half of additional revenue for which you didn't plan. And this becomes now what is a hot topic, a virtual teleport, right? A virtual teleport is pretty much an unmanned teleport where you do not know what's going on and traffic is routed automatically on the best link and the best direction based on the performance of the amplifier, based on the modulation, error correcting codes, traffic, and so on. And here is artificial intelligence has to come into play, because there is no way you can do that into a network of distributed virtual teleports. At the end, the teleport operator, the way we see it, will probably lose the ability to assign bandwidth manually, which is a complicated and expensive effort moving traffic from one antenna to another and so on. And then we see exactly the same in a network of dynamic traffic allocation. We see exactly the same concept which we have today with Bitcoin mining, currency mining. We're going to have capacity mining. You will be able to sell your teleport services if you have the capacity. So traffic will go to you if you can handle it in the most efficient way. You might not even know that it's there, but it will be used in an artificial intelligence with machine learning algorithm. So it is a concept which we believe is going to come. We're going to have this capacity mining. Teleports will be, inspected remotely, see the capacity, and then selected and get paid based on the traffic which is being used. That requires power. That requires power. Yeah.
That's really interesting. Now, I'm going to ask you both to sort of build on that model. What does that look like from your side first, Christy, and then I'll go to Daniel in terms of capacity mining? What would that look like as a business model? Because we've got a lot of teleport operators out there and companies, interestingly enough, we just did a podcast yesterday, who are in the business of providing services based on the teleports that already exist, right? So what does this model look like?
For example, you have the 5G network being deployed. Yeah, they need a lot of traffic to be transferred, and they will not use the satellite unless it's really needed.
Right.
For backhaul, they will look probably if you enter the agreement with them, they will look for the teleports in the area, and they will say, I would like to have this traffic, but I don't know on which frequency and how much power I need to transmit. This might change from case to case, So it has to be a turnkey service from the teleport in which it says, here is the key to my teleport, transmit whatever you want, at what power you want, and I will charge you based on the traffic.
Right.
You need to have the capabilities, otherwise you're losing the customer. Nobody will have time to switch manually in the teleport antennas and amplifiers and answer the phones I need to do, because those teleports will be unfortunately unmanned, I believe.
Yeah, no, I think you're right. Daniel, as you listen to this model, where does machine learning, where do you guys see, machine learning playing the role here? I think it's kind of obvious, and Christy has mentioned some of it, but can you maybe elaborate on it a little bit further?
Yeah, so I think Christy is giving a sense of like, how's it supposed to work? And we have analogies that are in existence in other fields to see how it could work. So if you think about, for example, the switch from circuit switching to packet switching, there was this like increased allocation of networks because of a new protocol. Right. The difference is that unlike the internet, satellites are not a charity, right? Like you have to actually like buy the bandwidth and see how much you're using. And it's not just like, oh, more efficient routing, great. And so we have things like examples of protocols that are set up to be more efficient to use existing networks, but they're missing the pay part. And then you have on the other side, things like Mechanical Turk, where you have an API to a physical system of humans behind keyboards, where you do have to pay for capacity. And so there are like design patterns that give us a hint about how this is going to work. And so the place that artificial intelligence works is at that intersection of automation. So there's one part of the answer is going to be protocol, which is not AI anything. It's just here's a protocol for interchange of bandwidth and value. The AI part is going to be in the operations. So making sure the humans don't have to be involved to do these transactions. Mm-hmm. And also in things like the negotiation, the market making, like the whole non-network operations side of the business will also need some AI and automation. And so those things together, so for a good example is like if I can forecast that there's going to be more traffic, I should charge more, or I should offer less capacity, or like if I know in advance that there's going to be a bottleneck, don't try and go to the market and sell a thing you may not have later. Right. So yeah, so there's pieces for AI and there's pieces where you don't need AI, but you need something.
Yep, exactly. But as I listen to this discussion, it just seems to me that increasingly AI is going to play a bigger and bigger role, especially if these teleports begin to migrate into a virtual format, and the networks become as complex as they are. Capacity mining comes into being, and a lot of the other things that we talk about come to pass. So I think you guys are sitting in the catbird seat with regard to being the AI provider. Gentlemen, we're getting some questions in, and I want to stop so that you guys can answer them. Giovanni, I believe she pronounces her name, asks, are the new GEO satellites in Q and V band using TWTA or SSPI technologies? Christy, I think that's yours.
Well, we are not ready in solid state to do Q and V high power amplifiers to the level that will be required on a ground station. We can do those to have inter-satellite communication links because of the free space loss is much lower in the space that's on the ground. I think that there will be a migration to Q and V as the demand for higher bandwidth will become obvious, but we are not ready today.
Right, not ready today. Okay. I just want to take a quick pass at a couple of other issues in the time we have. LEOs, obviously, that's one of the big news makers in our industry right now, and there are a lot of things happening in Canada with Telesat, obviously, and SpaceX and OneWeb, and so we know what low Earth orbit satellites are and what they're starting to do. Christy, when you at Advantech Wireless consider the LEO regime, where do you see the requirements coming from the provider?
Well, so we are participating in pretty much every LEO constellation.
Are you?
Right now, being SpaceX, Amazon, and Telesat, and so on. At least with our technical capabilities and proposals. The ground system for the LEO constellation is extremely complex. It is extremely complex and requires this RF orchestration at a global level. The amount of power that is required on these satellites is also extremely high. Why? Because now we are talking about sending a lot of data, gigabits of data, so we will need to use very high modulation codes, 1024 QAM and so on. For that, you need a different class of amplifiers all by itself. So we would design and we would work, for example, classes of amplifiers that can give you kilowatts of power, and also will provide some sort of feedback down converted from the RF. So at the digital side, there can be incorporated a machine learning algorithm which will make the link between the modem digital data and the amplifier RF performance. And by doing this machine learning algorithm, artificial intelligence will then be generating the best and the optimal operating point of the amplifier and do predistortion and error correcting codes. At the same time, congestion is very important. So we need to be able to do congestion prediction, and we need to do smart interference avoidance. That has to be done in a massive LEO constellation with thousands of satellites, has to be done with an artificial intelligence algorithm. It cannot be done manually. In any case, the need, at least from our point of view, the need for higher power is not a problem anymore. Is how do you operate these power amplifiers in a most efficient and effective way? Because when you design and when you install, for example, a 20 kilowatt power amplifier, it's a complex system, all modular, plug-in modules and so on. And if you install it in an unmanned teleport, then you have to have predictive maintenance. And that's where people like Daniel needs to come in and help us.
Yeah, I want to ask Daniel about that. Christy, are you now rethinking the design of power amplifiers? Are you guys in the skunk works because of these enormous requirements and these complexities? Do you have to modify products, build new products, or can you go with what you have and just kind of reconfigure them? How's that working?
Absolutely, absolutely. We are designing for a few years now a completely new class of amplifiers, C, X, KU, and KA band, very high power,
Mm-hmm.
with specific characteristics and linearity that are needed for the LEO operators. And this is a completely new class, different technology.
Yeah. Yeah. No, I would think that would be the case.
Yeah. So, and in some cases, for example, we're doing now deep space communication links where we need really high power amplifiers.
Mm-hmm.
And interesting enough is that these amplifiers are designed to operate not only as a typical satellite amplifier in constant wave, but they can operate in pulse mode. So install, a 7 kilowatt pulse amplifier on a 30-meter antenna, and you have a powerful radar that can detect debris in the space and junk in space. So it also serves a dual purpose.
Yeah, and that's the latter is an increasingly big issue, as we're finding. Daniel, over to you on the LEO part of the discussion. Christy talked about the need for predictive maintenance and the algorithms that will allow these very complex constellations to function. Is that where you see the business coming from for Lemay.ai, or is it in addition to data analytics, Earth observation types of applications as well?
Earth observation is very cool. There's a whole set of interesting applications, both defense and commercial.
Yeah.
It's interesting to me the bands that they picked, so you can do crowd monitoring, why they picked for different Earth observation. But I want to focus actually more on the SATCOM part. There's when you talk about specifically the operations of the satellite network, there's a trade-off between symbolic representation to do the control and something like deep learning, like just looking at the past to predict the future. What I mean by that more specifically is you can't just look at the past because the industry is growing. If you have a LEO constellation that's brand new and people are coming online and the capacity is going up, you can't just treat yesterday as if it's another copy of tomorrow, because they're not. And so if you only learn from how did things used to work traffic routing wise and bandwidth allocation wise, you're making a mistake, because tomorrow doesn't look like today. There are these periodic patterns where you see, for example, time of day has an effect. We talked about, Christy mentioned, weather has an effect. And so there are these data sets that do have strong correlations with how much capacity you have, how much bandwidth you need, but you got to be careful to include rules, not just learn from data blindly, because those rules are more logical than just saying, I'll look at what happened before in a thing that's growing, a thing that's changing. And it will continue to change. I think even if we weren't in a growth mode of capacity, things would still be changing because of protocol changes, because of hardware changes. And so there's this fundamental trade-off, which is where we get to help by going do consulting. The trade-off is between logic and just learning from data. And you have to combine those somehow to make sure you're getting the best of both worlds. Not just rules-based, because then no AI, and not just deep learning, don't think too hard, just feature extract and train models, because they're always going to be yesterday's technology.
Yeah, and it almost sounds like you're trying to combine, the scientific process with the active creativity, because you're always observing, and then you're trying to make some decisions.
I know this is a bit meta, but I like the system 1, system 2 idea. The Daniel Kahneman, there's two kinds of AI. Yeah. One is the just very, very fast calculation to make quick predictions. And the other is sit down, think hard, and those two need to be combined in this problem space, because there's a bit of both.
Yeah. Well, that's a nice segue, Christy, into another area where, again, the ecosystem is changing, which is security. There, the concern isn't so much profitability in some cases as in protection, of a national interest, for example, or something more significant. Well, I guess there's not much more significant than that. But it's all about being able to, as Daniel said, think quickly or take action quickly based on data, probably after having thought through the issue over a long period of time. So 1 and 2 and at work. I know you have some examples with regard to how security systems, radar antennas can use AI to take actions in a more rapid way. Can you elaborate on that a little bit?
Yes, sure. So we are a Canadian company. We are registered because we work with defense companies and organizations. We are registered with the Export Control Canada, which is ITAR certified. And recently, we just were told that we have to use only secure clouds, and that's quite an important change for us. And if we look, I mean, who is now today into this kind of business model and promoting is Microsoft. Microsoft has this secure clouds, perfectly secure, and they start to integrate the clouds with satellite operators. So they recently signed an agreement with SES to do O3B on the cloud, secure Microsoft cloud centers, because there's tremendous amount of data that needs to be transferred. So we're going to have a new set of teleports, which nobody envisioned before, just because we need to move data from secure clouds. A secure cloud cannot be located in a third country. A secure cloud needs to be located in your own country, otherwise defense will not accept it. So if you talk of an organization, or let's say let's like United States DoD with operation on military bases all over the world, those secure clouds have to be there. Then you need to move that data quite fast with low latency. And you need to use satellite for that. There is no other way. And LEO is a perfect way, because you can have a point-to-point communication without going through a third-party teleport. But you need power. Yeah, so you need tremendous amount of power, and that's where our expertise is. Another example would be here in the Canadian Arctic, where we have deployed about 50 satellite stations that are taking the signal from the radars and sending the information to radar processing centers, which is integrated into NORAD, the North Atlantic Early Warning System. It is today, I would say, probably a manual process. It takes a lot of phone calls between people to say, hey, do you see what I see? Do you think that this is what I think? So artificial intelligence and machine learning need to eliminate this waste of time and to provide from a distributed network of radars, for example, video and not only military grade radars, air traffic control and so on, other transmitters and so on, a comprehensive set of information that would allow the decision maker to take a decision in seconds instead of taking it in hours. Yeah. Because in defense, you don't have hours at the disposal.
Yeah, correct. And data is being processed rapidly across national radar systems, and so as you say, national security now has a velocity to it that it probably didn't have 20 or 30 years ago. Daniel, anything you would like to add to that?
Yeah, so we're doing some work on that. So we got this NATO project doing long-range radar, air command and control, data fusion. Same thing that Christy was just talking about. So yeah, that's in the public domain. That's cool. And yeah, we also have the controlled goods, and I like to view these things as like a barrier to entry. They're not a plus; they're just like a necessary thing you have to go through to deal with controlled goods and do defense stuff. But like as an engineer, it doesn't help you. It's just a thing you have to do. The actual technical challenge, which is pretty interesting, is not as much in the making the decision quickly. It's more in knowing what to do with the information. Radar is a great example. Even when pointing straight down from space, you get conflicting information. You get, ghost signals, things happen that I don't know if everybody is aware that like the quality of the information you get isn't necessarily good. And so you have to make like incomplete information decisions about, great example on a network. There's a Super Bowl. It has a date. You know it's going to happen, but it's kind of like a one-time event. It's not in your like weekly time series type thing. If only someone would account for it, you would know like, oh, I'm going to have a spike in traffic because lots of people are going to be streaming it. But someone has to like do that. The system's not going to do it itself. And so there's a lot of these one-off, like if there's a military exercise and everyone knows about it and it's planned super in advance, but if the network operator doesn't plan for it, then eventually when all that capacity is taken up, all of a sudden there's no more space.
Right.
And so sometimes it's really obvious things, but it's just not in the cards right now. And so that's where automation will help to avoid the necessity that humans are very actively managing the network.
And this can apply both obviously to a conflict which breaks out somewhere, or also and a national or a national disaster. A natural disaster, human disasters break out, right? These things are unpredictable. And so at that point, it really becomes important to have a machine learning capability that can sort it out quickly, yes?
I want to make another point, though. That's the case that everyone talks about. What they don't talk about is a regular Tuesday when nothing's happening. You don't want alarms to go off. It's not just about in an emergency making the right decision. On a regular basis, the actual network operator is like, don't set off alarms for no reason. It pisses everyone off. And when something's really wrong, we go like, oh, it's probably nothing. So it's really important on a regular day to be right also.
Yes.
Not just like the Russians are coming, right?
Right.
That doesn't happen too often.
So the cry wolf parable still lives.
Absolutely.
In the machine learning age, yeah. You know, when you talk about the data coming down, it's not always reliable. Is there spoofing going on among countries?
There's everything, but how much are you going to talk about it?
Okay.
Not much.
We'll take that as, yeah, probably, Lou, but that's all we're going to say. Okay, very good. And you know, what you just said, Daniel, is true as well because of for cities. And I know cities, of course, are increasingly using satellites to manage, you know, their water systems, to manage their infrastructure, their daily lives. And yeah, a mayor on a Wednesday, you know, doesn't need somebody crying wolf, but he does need his garbage picked up. And increasingly, that stuff is data driven, isn't it?
Yeah, and there are practical problems like urban canyon. There's like real engineering problems, and adding new ones like, oh, my thing that was supposed to help is actually hurting because it was wrong some of the time. Customers don't appreciate that at all. Like, you were supposed to help, but now you made things worse. Thanks.
Yeah, and that can make a one-term mayor a one-term mayor, as they say. Well, you know, speaking of cities and economies, my last area that I want to explore with you guys is this idea of expanding the economy because of these new ecosystems that we're putting in place, these new business models, the new need for satellite, and all the things that we've been describing today. Telesat, for example, Christie is creating 600 jobs in Quebec province. I mentioned places like Tallinn, which are into this business. Probably a lot of the reason is security, because they are one of the most cyber secure, smart nations on earth, which I mentioned. But what's happening is they're producing startups for the sector and the regional economy in big numbers. What do you see happening in Canada? Is this going to continue, and will there be a talent lack as a result of it?
Well, I have to say that I have never seen in 25 years since I am in the satellite business so much money invested in satellite. Tens of billions of dollars. Amazon, SpaceX, Microsoft, Telesat, and so on. Mm-hmm. There's a whole industry which is coming now today. All young entrepreneurs and startups with brilliant ideas. You know, we have here in Canada companies like Kepler, who's doing, you know, K-band constellation of LEO satellites out of Ontario from Toronto also.
Yeah. And he's manufacturing his satellites at the university.
Exactly. So the interesting part is that makes the satellite industry interesting again, you know, because young people start to consider satellite industry, which was not the case 10 years ago. We were really lacking talent. We couldn't hire people. You know, we had to scout the entire planet to find a couple of engineers or technicians. It seems to be that is reversing right now. There is interest because the technology is so hot and sexy and very interesting. So young people are interested and they will join us. And that's why we actually pushed to get this SSPI Canada chapter launched in order to bring the interest of the entire community, universities, schools and industry, all the industry, all satellite industry like the Telesat, plus the new ones that are coming. So to create this ecosystem, because the talent is not quite there, the schools need to contribute to that. And they are doing it right now. There are very interesting programs in Canadian universities, in Waterloo and here in Concordia and in many other places in Alberta and so on, doing quite interesting satellite communication programs, artificial intelligence, incubators, a lot of money here in Montreal. Large companies investing in it like Thales and GD and so on. And then in Ottawa, plenty of startups and all over the place. All of them will need engineers and technicians. So I think the future for the industry is quite bright, to be honest.
Yeah. Well, Daniel, that must bode well for you. Do you, first of all, you're in a hot and sexy business. Congratulations.
Thank you.
I was going to ask you, do you consider yourself hot and sexy, but do you consider yourself part of the space and satellite industry?
Yeah. So we actually have biz dev, a person on our team. We've got 20 people, and his portfolio is aerospace and defense only. And so it's a big part of what we do. Obviously, we had to jump through the hoops to be able to play the game. Canada as a whole, not just like our company as like a micro example, has a big head start. The godfathers of AI are all Canadian or did their university in Canada. Canada has kind of a big advantage in terms of we have excellent universities across the country. We have capacity to produce many students. It's seen internationally as a place to go do business. We do a whole bunch of export business. We have more outside of Canada business than inside of Canada business. And so the way that we look at the world is we're a teeny little company of 20 people in a big giant ocean of work to do. And so really, Canada is producing a lot of startups. It's not clear what the outcome's going to be, though. Canada has a long history of like seeming to do really well and then dropping the ball. So it's yet to be determined if like it's going to all work out great for Canada, but Canada's doing the right moves. SIFAR funding has been distributed across the country. Like the feds put some money in, they could put more. And industry has to do its part too, to not lose the best and brightest minds to America like we usually do. So far we haven't, but will it happen? It still could.
Well, I think that's a good question to ask here as I close this segment, which is you're exactly right. You have tremendous schools. I mean, University of Waterloo is probably one of the best engineering schools in North America, at least one of the top 5. You do have enormous talent. In addition to the godfathers of AI, you had the godfathers of the smartphones that grow up in Waterloo, right? Mike Lazaridis, Jim Balsillie. They stayed home. They built RIM in the tech triangle up there. But as you say, a lot of companies do leave and come to my country and others. A lot of it, the reason is because of the funding issues, the venture capital ability and so forth. As you look at what Christy was talking about, the talent, the ecosystem around you now, do you see Lemay.ai staying home?
We're going to stay home, but for a different reason. We're in Ottawa. We're kind of like right in the middle of the defense industry. We kind of found a cozy place to be. And so like many like government affiliated companies, it kind of makes sense. Like the structurally it makes sense, but the rest of the economy isn't like that. You never want to be in a place where like the economy equals the government. And so more broadly speaking about like the Canadian ecosystem, the verdict is not in yet about will it go well. The conditions are good, but it could be screwed up in either direction. Either the industry itself could just leave if the taxing situation is better in America and people just kind of get up and leave. And similarly, on the government side, if the universities stop producing the talent that they are now, right now they're in an excellent position, but there's lots of hope and promise and it hasn't yet been delivered. So it could be in the next 3 to 5 years, things go amazing, or it could be that they just kind of fizzle out. Every country out there has an AI plan. Canada's came out very, very early. We were one of the first, but every other country was like, oh, wait, that's a great idea. I should do that too. So do we lose our edge? Don't know yet.
Yeah. Well, we'll certainly stay tuned to this channel to watch, because this is an issue I think we're going to be talking about in future SSPI Canada events. So, Daniel, I really want to thank you for coming. We've got a surprise ending for everyone today, so I want everybody to stay tuned. But Daniel Shapiro, Christy Damian, thank you so much, and thank Advantech Wireless for all the work they've done to promote the SSPI Canada chapter as it grows.
And
thank you, gentlemen,
for having me.
Thank you, Lou. Thank you. It was a pleasure.
Our next event will be in July or September. I don't think they're quite sure yet, but it's going to be a virtual networking event. So we'll keep you informed on that. And you know, we're delighted that the SSPI Canada chapter continues to grow and to do events like this. And we'll, as I say, keep you informed. Watch for the Better Satellite World podcast every Monday at sspi.org, where we talk about issues just like this and more. So before we leave, I just wanted to share with you a new video that we've produced as part of our campaign to talk about all of the virtuous things that satellites do for the world, as Christy and Daniel said, every single minute of the day. And this is something that's being done for a group of people that I think you'll hear more about their story as we go forward. So this is Lou Zaccarella on behalf of SSPI and SSPI Canada, thanking you for joining us. We hope you work with us to make it a better satellite world. And now, the Better Satellite World video.
High in the sky, amid Peru's tallest mountains, live a people from another time. They are called the Queros, and they are the last traditional community of the Incan nation. Life at high altitude is hard. The Queros raise animals and farm the rugged land as their ancestors did, and their lives have long been marked by food insecurity, high child mortality, and poor education. In 2010, a student named Hannah Ray Porst came to live with the Queros for a university project. When her research came to an end, she asked villagers how she could thank them for their hospitality. What they needed most, they told her, was a school. That conversation stayed with Hannah Ray, and back in America, she began raising money. Within a year, she was able to launch construction of the school, and also moved to Peru. To keep the improvements coming, she founded a charity called Wilka Yachai, which means sacred wisdom in Quechua, the language of the Queros. Over the next years, Wilka Yachai helped the community build more schools, centers for adult learning and health, fish ponds, and greenhouses. But while making life better for them, the charity also wanted to preserve the culture that gave meaning to their lives. That would take more than building projects. Wilka Yachai went in search of a way to bring the internet to the Queros. It found Kidnected World. That's an NGO that brings interactive education to indigenous children in the Americas and Africa, with the help of a company called Speedcast. Speedcast is a global communication and IT service provider. It serves thousands of energy platforms and mines, cargo and cruise ships, governments, and businesses around the world. Speedcast advised the charity on buying the right technology and sent staff to install it. The company also donated a year's worth of satellite internet service. And the internet helped build a better future. It brought medical advice for the sick and connection with distant family members. It connected teachers from far away who taught the math, physics, and engineering needed for building projects that keep improving the Queros' quality of life. Craftspeople began to sell traditional woven goods online to a global market. Kidnected World donated its online platform of tools, meetups, and content, and Queros kids found new ways to celebrate and share their culture with others around the world. When COVID-19 reached Peru, the government imposed a strict quarantine on indigenous groups. With reliable internet service, the Keros have been able to stay safely sheltered in their high mountains, but still connected to the world.
So at the start of the coronavirus pandemic, we had advised our compadres and Keros to stay in their mountain communities and to keep visitors out. They have done that. Our Speedcast internet connection is our only means of communication with them, and it's working really well. We communicate with the community members all the time, and they report that they are all healthy. Thank you, Speedcast, for providing this lifeline for the Keros. Y cuídate, por favor.
Space and satellite, the world's invisible, indispensable technologies. Brought to you by Space and Satellite Professionals International with the support of Speedcast.